Hello, Joe once again. Here's a little project created in HVAC solution. You'll see there's an air handler, an airflow diagram, hydronic hot and chilled water systems. This was basically created in just a few seconds by using our import wizard. We can actually import Trane trace load files into HVAC solution and then build these systems and do all the calculations and select and schedule equipment. And then put it in Revit. Obviously, that's our end game. So let's just come in here and do that. File, I'm going to come into import. I want a Trane trace file. So when you're using Trane trace, you can save your file as our file, an HVAC solution file. You come, and then it appears like that with a little checkbox. I'm just going to click on that. And now we're going to bring you to our wizard, and you want to round off the CFM, okay? You want to do one space or show every space or zones, so some options there. Okay, there's the name of the project. We want heating and cooling. So we're just going to take you through a series of questions. Okay, yes, I would like ducted relief. Maybe you want a terminal unit. You see all the different options we have for terminal units, VAV, VRF, heat pumps, whatever it might be. Let's just put a VAV on the system. I want hydronic heating and cooling coils. Then it'll build a hydronic system for me. My terminal unit, we have different products we can pick in here. Supply fan, one. We can put manufacturers in there as well. Return fan, one return fan. Okay. MERV rating, everything we use per ASHRAE. So MERV rating for this. Maybe you want angled filters on that. That heat loss is what came from the Trane trace loads program, along with these temperatures, the space, 71, 74, humidity, the size of the space. The CFM was taken and brought into HVAC solution, as well as ventilation information. We also do the ASHRAE 62 and ASHRAE 170 in the software. Any exhaust would appear right there, so there's none exhaust. Now we're going to build the hydronic system, and you can see we like to show control valves because that adds head, and we want to get those in our diagram. So just different choices on where you want your control valve, three-way, two-way pumps, inlet or outlet of coils. Yes, let's do a boiler, an air-cooled chiller. We can build all sorts of systems you can see there. One boiler, we can put a manufacturer in there, Brian maybe. One air-cooled chiller, we'll put air mech in here. Primary, secondary, yes, that's what my pump configuration wants to be for that. Cooling, we'll go with manifolded. How many pumps? Primary, secondary. My heating expansion tanks for both systems. My air separator. When I hit next here, there's my air handler. There's my airflow diagram. There's my hydronic hot water and chilled water system. So let's look down here real fast. I have 36 tons of cooling. My size to that coil, based on my diameter, is 3-inch pipe. If my load changes, I rerun loads, maybe I end up being, 60,000 CFM for the heating, 60,000 for cooling. So what just happened is now instead of 3-inch, I'm now 5-inch. I'm now 165 tons of cooling. When you model your system in HVAC solution, as your loads change, your air system and hydronics controls, whatever you might have as part of our system, will change as well. So where do we fit in? Loads on the front end, we import them in. Revit's on the end game. We take this, we put these schematics and these schedules in Revit. We also map this data to the shared parameter in the Revit model, and we can actually create schedules right inside of Revit if you'd rather have them done that way. Anyway, that's just importing a Trane trace file and building a simple system. Thanks for watching.